Welcome to this lecture. And in this lecture, we are going to be learn about the vector in the data structure. The vector class implements a growable array of an object. Like an array, it contains components that can be accessed using an integer indexed. However, the size of a vector can grow or shrink as needed to accommodate the additions or removal of the element. Each vector tries to optimize the storage management by maintaining a capacity and a capacity increment. The capacity is always at least as large as the vector size. It is usually larger because components are added to the vector. The vector storage increases in the chunk size of the capacity increment. An application can increase the capacity of the vector before inserting a large number of components. This reduces the amount of incremental relocation. Vector also has a branch of method around the enumerations and the element retrieval, which are different than the list interface and developer. So, especially those who learn Java before 1.2 can trend to use them if they are in the code. All through enumerations are faster, then they do not check if the collection was modified during iterations, which can cause issues and given that the vector might be chosen for its synchronization with the attend access from multiple threads. This makes it a particular precocious problem. Using of these methods also couples a lot of code to vectors such that it won't be easy to replace it with our different list implementations. Mm, So here we just see the vector is a class which is similar to the traditional Java array. Expect that it can grow as necessary to accommodate the new elements. Like an array, elements of a vector object can be accessed via indexed into the vector. The nice thing about using the vector class is that you don't have to worry about setting it to a specific size upon the creations. It shrinks and grows automatically when necessary. Vector implementations are dynamic array. It is similar to the array list, but with two differences. Because vector is synchronized, vector contains many legacy methods that are not part of the collections framework. Vector provides to be very useful if you don't know the size of the array in the advance, or you just need one that can change the size over the lifetime of the program. Now we just see the program of the vector in our Java data structure, which illustrate the several of the methods supported by this collection. So here I just import a library which is a name of java.util. We have the class name which is a vector demo, and then the main method which is public static void main and string arguments. Now I just initialize the size of the three incremental array. Vector v which is equal to new vector. So here the size of 3 and then the size of 2. Now system.out.println and the print line here is initial size and then plus v dot size here. Now here I just write system dot out dot print line and the print line here is initial capacity, and then the initial capacity is v dot capacity, which is used in the vector. Now here I just write v dot add and add the elements. Then here I just write new, and new is integer here, and then it's 1. Now I just copy for 1 time, 2, 3. So it's 2 here, and then 3, and then 4. And now system.out.println, and the print line here is capacity after 4 additions. And then I just concatenate the capacity. So v dot add, and the add is an element here, and it's new, and then the data type, which is double, and the value is 5.45. Now system.out.println, and the print line here is current capacity, which is the concatenation of v dot capacity. Here I just copy this code and paste it 1 time for the double, and then change the value, which is 6.06. And here v dot add, and add is element here, which is new and integer, and then the integer is 7 here. Okay, now v dot add, and v dot add element, an element which is equal to new. The data type is float, which is 9.3, and then v dot add element, which is new integer, and then the integer value is 10 here. System.out.println, and the print line is current capacity, and then concatenate v dot capacity. Now here v dot add element, and this is add element, and now where new is integer, and integer here is 11. Then v dot add element, and new is integer, and which is 12. System.out.println, which is first element, and then concatenate integer, and it's integer, and then v dot first element. So I just print the first element, and then create the and then concatenate the integer, which is v dot first element. Then system dot out dot println, and the print line here is last element, and then concatenate integer, which is v dot last element. Now I just used if statement. So if and v dot contains, so v contains new integer which is, and its integer which is 3, and then system dot out dot println, and the println here is vector contains 3, and here I just enumerate the element of the vector. So enumeration, and the enumeration which is v enum, and then which is equal to v dot elements. And now system dot out dot println, and the println here is slash n, and element is vector. So while v enum dot has more elements, which is check it's return true or it's return false. So plus, and then empty string, and system dot out dot println, and the println is null. So it's not a concatenation here, so I just write the while loop here, and then system dot out dot println, and the println is v enum dot next element, and then I just concatenate an empty string. Now I just checked the output for this code. So here you can see we have the initial size of this is vector is 0. Then we just define the initial capacity of the vector is 3. You can see here this is the initial capacity of the vector which is 3. Then capacity after 4 addition is 5. You can see here we have the capacity after the 4 additions is 5. Then we have the current capacity, means after the 4 capacity we have the current capacity is 5. Then after that we have the another capacity which is 7, and then we have the another capacity which is 9 here, and then the first element I just print which is 1. So this is the first element of the integer which is 1, and the last integer value is 12. Then vector contains 3 integers, and then first element of the vector is 1, 2, 3, 4, and then you can see a 1, 2, 3, 4, and then 5.45, and then 6.05. Then we have 7, 9.3, 10, 11, 12. So we have these element of the vectors which is the print here. So this is a simple example of illustrate a several of the method supported by vectors. I just tell you a simple difference between the array list and the vector. So in synchronization, array list is not synchronized, which means that multiple threads can work on array list at the same time. For example, if one thread is performing an add operations on the array list, there can be another thread performing remove operations on array list at the same time in a multiple threaded environment. While vector is synchronized, this means if one thread is working on the vector, no other thread can get a hold of it Unlike array list, only one thread can perform add operations on the vector at a time. So this is the vector in data structure. Thanks for watching this lecture. See you in next lecture.